Welcome to the Bug Bash podcast, where we talk about all things software correctness and reliability. I'm your host, David Wynn. How do you test for bugs that only appear when a user starts clicking around frantically, or when asynchronous data loads in an unexpected order? Standard UI tests often miss the subtle stuff that happens all the time in stateful dynamic applications. In this episode, Paul Ryan and I sit down with Oskar Wickström, creator of the QuickStrom framework, among other things, to explore how to apply generative testing to the complex world of user interfaces. Oskar argues that you don't need to be a formal methods genius to get real value out of the approach. Even simple properties can uncover deep bugs, like ensuring that a loading spinner eventually disappears or that a screen never goes blank. If you've been intrigued by property-based testing, but intimidated by the thought of writing complex formal models for UIs, stick around.
Okay, my name is Oskar. I live in Sweden, and I've been working remotely for a good number of years now. My background is sort of a generalist, doing lots of web development, cloud, all kinds of stuff. And then I got into functional programming and eventually into property-based testing and various forms of that, which became a big rabbit hole to dive into. So, yeah.
For sure. Can I ask what piqued your interest? Because that you don't often hear the functional to property-based pipeline going on. That's pipeline joke right there.
Yeah. Well, I think it started like I was going to a lot of FP conferences in Europe, and I think that there is a strong presence of like the quick check tradition and stuff going on in FP, right? But I was looking at that at the time with, I guess, a little bit of a skeptic mind, like looking at all the list sorting examples and all that, and it didn't really stick for me then. And it was at work when we were migrating from some kind of a legacy implementation of a system into a new one, which was actually written in Haskell, believe it or not. And we did a sort of testing setup where we used the old system as an oracle for the to test out the new thing, and used the database in a full sort of real way, so to speak. And that was eye-opening for me. Like, oh, this is practical now. That's where I started seeing it. I couldn't really jump on when it was so theoretical, I think. So that's kind of what got me hooked. And then that snowballed into other projects I was doing on my own time. That was not a work thing, but it was an open source project for a video editor for podcasts, actually. Maybe fitting for this. I was, or screencasts rather, because I was producing my own screencasts around Haskell programming. And I thought like the experience of editing screencasts was not at all like, editing code. So I wrote my own screencast editor, which had like Vim bindings and structural editing and sort of Emacs kind of, what's it called? The S expression where you can move around and splice them and do all these maneuvers. So the video editor was sort of that, really. And I was hacking on this and couldn't get everything to work. I started like investing in property-based testing for it. And that really just clicked even more. I was banging my head at those tests for like 2 weeks. And then after coming out of the cave, everything just worked. Like it was full of subtle bugs, strange like off by ones and stuff that I couldn't find. And it was so frustrating to try to, run the UI with some kind of printf debugging, whatever, and try to hit those edge cases. But with property-based testing, it's sort of just unfolded, as you may know it can do.
Awesome. So talk us through that a little bit. How do you validate as you start? We can use the screencast editor as an example, or any other project that you may have in mind. How do you go about validating the tests that you write with this type of approach, right? What do you know what to put under it? What do you know what to keep out? What feels like the right what makes it feel right so that it unfolds before me in this beautiful array so that I can think less and I can just fix and move on?
Yeah, it's a good question, and I think it's one where I doubt myself. However much energy I put into this, it's sort of I will always doubt myself that am I really testing the right things, or am I really like exhausting the state space in the way I want? It is a very much like an unsolved problem, at least for me. I don't know about antithesis and like maybe it's a better situation, but like tuning generators, all this stuff with property-based testing, that is hard still. And but let's maybe zoom out a bit. Like with property tests, you have the whole generative testing approach where, I mean, in a sense, like you have randomness as a way of helping you figure out things that you can't figure out yourself. I like to think of this when you're writing, let's say, a blog post or a book or an article or something, and you try to go into this sort of editor or review mode for your own writing. That is a very tricky thing, and it really helps if you like print out the text and review it on paper, or if you review it the day after you wrote it or something like that, just to find this way of like switching your brain into very different mode, like adversarial mode for your own writing. I think it's the sort of same challenge with writing tests, and like regardless if it's example-based tests or if it's property-based tests or whatever, it's tricky to get into this mode while you're at the same time trying to like develop the thing that you're testing. So long answer, but it's sort of still tricky to do that, I think. But with property-based testing, it's a lot more, it is easier to find ways to test things that you hadn't thought about before. The other part of that challenge, I think, is getting a good intuition on how you write properties. There are these sort of collections of patterns for properties. So it could be things like the Oracle thing I mentioned before, like you have two systems that should functionally behave the same, and you can sort of compare one against the other, feed them the same inputs, expect the same outputs. There are a bunch of other patterns. There's this F# for fun and profit, I think, blog, which has a great article on these patterns. Probably other.
I send that one out to people all the time.
Yeah, it's a very good start. And it has like these little graphical examples. Even you can get an intuition, like the maze solving thing or whatever. Like, I don't know them well enough to like iterate through all of them, but there's a bunch of these, like item potency being one thing. Different sort of abstract properties that a lot of, like when you start getting comfortable with these ways of writing properties, you start seeing them more naturally when you approach a certain piece of code, and you can sort of, if I squint at this is just the same as that other thing I tested with properties, and I wrote properties for. So I think you sort of exercise that muscle in a way. Yeah.
Well, let's zoom out a bit, because I have read that article recently. And so a couple of the things that are mentioned in that meta grouping of things include commutativity, which would be two paths to the same destination, right? If I add 1 and 2, I should always get 3, even if I add 2 and 1. Reversibility. So if it's like an encode decode operation, then that should always come backward and forward to the same result. Oh no, now I'm going to fall down on my own thing. You already mentioned item potency. There's also one where if you can prove a part of a data structure holds a certain property, you can prove that the bigger data structure holds the same property with recursiveness and stuff.
Inductive property.
Yes, thank you. In inductiveness. And those seem clear to me at the functional level. How would you suggest someone who has heard about property-based testing and hasn't necessarily dived too deep into it, how do they start thinking about that at higher levels of abstraction in the UI, where JavaScript sort probably works well enough if I pretend that enough of those data values don't exist, right?
Yeah. I think it's like, it gets trickier at higher levels to find these neat sort of algorithmic or algebraic, whatever sort of structures or patterns. You can still probably find some of them, like idempotency is pretty common, for instance. But yeah, that it doesn't map so cleanly at those levels. If it's like a business, whatever app with the UI, it's not going to be like that sort of neat mathematical set of properties, perhaps. But I think when I started doing the UI testing, which we can talk more about in detail later, that sort of I approached that a little bit differently, I think. More trying to put my mind into some sort of product sort of mindset. Like if I was talking to someone which wasn't technical, and try to ask like what the system should work like. You can maybe tease out different kinds of properties from that as well. So like how users are supposed to behave and how the system should respond to that user input, how you should be able to, like if you have a web app, for instance, how you should be able to navigate or do certain things in certain orders, stuff like this. You might have sort of, a certain ordering you want to enforce, or maybe you other way around. You don't want to have a certain ordering and you should be able to do things in any order. You sort of have the commutativity example there again. So I think those things are also present, but even harder to find at those levels, I would say. Yeah.
Right. Like something where if you're talking to a non-technical user, you ask, should this be possible? And maybe they look at you like you've grown a second head.
Yeah.
Getting all of that tacit knowledge that exists in, people who just use Facebook have a very detailed idea of how Facebook should work, for example.
Yeah. And like a lot of these things are pretty natural to talk about in sort of like a certain instance. Maybe people aren't used to like abstracting that and thinking about, oh, this is this or that property or this structure. But when you bring it down to a particular example, you can talk about like, should this be possible? Should I be able to do this and then that? Or should this be visible while this is not? Yeah, whatever it is, some kind of rule. Yeah. So I think it's maybe also a skill in this area around like identifying these patterns is being able to translate them to sort of non-technical speak as well, I think. Yeah.
Just things like I shouldn't have all of these modal dialogues open at once, or I shouldn't be able to get to the user control panel without being logged in, or something like that.
Yeah. So like there are a lot of these which are very simple properties, like the ones you said. Like I usually bring up this example of like you should always be able to see either a login link or a little avatar with your menu, whatever configuration, which is sort of like a safety property for a web app in a sense. Yeah. Then there might be more, a little bit more advanced properties around, let's say you wanted to specify that you should always be at most 2 jumps away from the homepage or something, or you should always be able to do this certain action. And then you get into slightly trickier territory with like, I think, so we could talk about like the particular logic and stuff that I've used before, but you could almost think of this as sort of CTL kind of logics or different ways of representing those specifications.
Yeah, please do expand on that, because now I'm sitting here thinking about it's like, okay, I can see how I would make sure that there's either the little like fave icon up there with the little person or the login screen. I got that. How am I going to always make sure that I'm 2 hops away from the homepage or whatever it may be?
Yeah. So actually, with the stuff that I've been building, I'm not sure that is possible to specify actually in that logic. You would need some kind of better model to speak about that sort of structure, or I guess I think CTL would be more appropriate there to be able to say like all paths lead to paths that eventually get you 2 steps away from that. Then there is also like this gets us into a thing with testing, which like when we talk about this UI on web testing now, I'm drawing from like what I've been working on with a framework called QuickStrom, which is basically like property-based testing for web apps. And the way you specify the properties is with a logic called linear temporal logic. So a regular sort of propositional logic, you can have these formulas with like and or operators and implication and stuff like this. With temporal logic, you can say in this state, this formula should be true, and in the next state, some other formula should be true. So like if you take a really simple example, if one formula is just, let's say, x, and x represents some kind of whatever predicate you have. And with the temporal logic, you can say next x. That means in the next state, x would be true. And these states, they are like just a sequence of discrete states. And in the web app example, it would be like state jumps, whatever. Like you could do an action, you get into a new state and so on. You have this sequence of states. And you can specify with a temporal formula how, every sequence of states that has been observed should fulfill that formula or behave. So you could say like, where would be like always the login thing should be visible, and eventually you should be able to see this or something. Like if you have a spinner on a page loading data, you could say like, spinner visible and eventually error or content or success of some sort, right? So you could specify these things as well.
So you could almost define flows that are often when I'm talking to people about property-based testing, it tends to latch on in people's minds as invariant is often the term that people use, right? So I have to come up with the single thing that is always true in every case. But what you're describing there is essentially a mapping of transitions across time. So you can say, we expect the state to flow from here to here to here to here. And I'm going to make one up, which is always dangerous to do, but I'm going to make one up. Let's say, we're adding a new user and we expect that the username will have some sort of derivation of the first name and last name that was provided. And so the resulting username should have some conglomeration of those two things. We can probably do with a regular expression and kind of pull forward, and then it should show up on the screen and stuff like that. Is that the idea?
Yeah, like if that is a behavior over time. So let's say you have like a little wizard where you sign up, and then you could capture, like if they posted this first name and this last name, and then they click submit, they should end up on a user page, which has like, hi, first name, user, last name, something like that. Yeah, you could do that, yeah.
Or even something that wouldn't be expressible with traditional logic or traditional invariants. You could have something like, if I click the login page, it should open on the next state, the login modal.
Yeah. Exactly.
And then you also mentioned eventually. So you have next, like, if I do this, then this result should follow on the next event, on the next recalculation. I don't know how that's expressed, but you also mentioned this idea of eventually.
Yeah, eventually is different. So the next and the always, they are ways of sort of, we can take always. Always is for like invariance, something that should always be true. And there's this nice way of putting it with safety properties are like bad things never happen. You want something good to be always true, right? With liveness properties, or when using the eventually operator in temporal logic, it is as I said, a liveness property, which is a good thing eventually happens. And those are sort of complementary in a sense. So eventually is a little bit harder to wrap your head around when it comes to testing. And this is actually one of the, let's say, limits or problems we tackled when we did QuickStrom. So I did a first version just as a hobby project. And then I joined up with a researcher, his name Liam O'Connor, and we wrote a paper on the underlying logic for QuickStrom. And that tackles it somewhat tricky problem of testing being finite, but the theoretical behavior of a system is often infinite. So like a website has sort of infinite behavior. You could click around however much you want forever. Like that doesn't have any natural end to it, but your testing is not going to be infinite. And then you have to sort of deal with what happens at the end of your trace when you run a test for, let's say, 100 actions or something. You collect these 101 states in that case. What do you do at the 103rd state if you have something saying, eventually this should happen, and you haven't yet come to a point where it happens? You have no evidence of this being able to be true yet. Could be in the 102nd, but maybe never. You don't know. So we ended up with a logic that evaluates to a sort of four-valued logic, as they call it, which is definitely true. Okay, so like instead of just true and false, you have definitely true or definitely false. You also have possibly true and possibly false. So that's sort of the weird grayscale. So a test could fail by not being able to prove that something good eventually happened. Or it could fail with definitely showing that something bad happened. So if you have a safety property, like an invariant, you can either get a definite true, a definite false. Like, we know that there is a counterexample to this property. This has failed once, that's enough. Or you can get a probably true, because you could be testing a little bit more. Who knows? Maybe the next test case, if you tweak something, you would find a counterexample. So you're not sure. Like, you can't get a definite true. And with the liveness properties, it's the other way around. If you have an evidence of something being able to be true, that's definitely true, or it's probably false if it hasn't yet been shown that. So yeah, that's sort of where we ended up with that. So test results in QuickStrom are either definite or probable.
I like that. It makes explicit one of the challenges that you have when you take a generative approach, which is pick any number of iterations for anything that you're trying to falsify, right? You get this representation of, well, I didn't find anything wrong with it this time. ...
Yeah.
Labeling that state explicitly, possibly true, is a nice... I like explicit over implicit. There's some good things that we should definitely take from the Python world for sure. And that's a good way to do that. So let's take this back just a little bit more. One of the things you said earlier was talking about the two hops thing, that may or may not be a great property to test because it may not be calculable. If I'm correctly misinterpreting you there. How would someone who is just starting in this world have a sense for what is a good thing to start with versus a not so good thing to start with, and not fall in one of these holes where if they happen to be talking to you, be like, oh yeah, I shouldn't have done that.
Yeah. It's something that I myself fell into a few holes with, because a small anecdote, but we were using this at a previous workplace actually, and to test our web app, and we found some case where we sort of nested these eventually and always operators in a way where the checker sort of just exploded and got into, because the system, like, it is a little bit detailed, but it's sort of, if you say something like eventually X, you also can provide a little number that says try at least 10 states for this formula, because it might be, it's very hard to upfront say for the entire test run only do 100 states or steps, whatever. Instead, these sub-properties can themselves say, if you evaluate me, please give me 10 states to be able to give me some time to become true in the eventually case, or in the always case, I want to see at least 10 good examples of 10 good states. So when you nest those, they sort of create this weird behavior where they just pull more and more states, and you can get into this infinite loop there, which we did. And that turned out to be theoretically like super tricky to solve, and something that Leah went off and tried to do sort of solve in another direction. And I think from my practice in this area, I think keeping stuff pretty simple is good. And like one thing that I started out with when doing QuickStrom, the first version, was really like explicit state machine modeling. So I was reading a lot about like TLA plus and that stuff back then. And that is like fascinating and great stuff to learn. And then in that sort of way of specifying, you talk about a step function often. So you have like a state machine with a step function. And the step function says, from one state to another, this is the relation. And that's like all there is to the state machine, really. And you can do this in QuickStrom. You can say like for any state, the next state should have this, they should relate to each other this particular way. And you can express all the transitions from state 1 to 2 or whatever, to adjacent states. That is very powerful, but then also these specifications become kind of complicated because you have to specify basically everything that can happen, or have some kind of default fallback case. Maybe not great. So another thing I realized after a while doing this, even if that was super powerful, and we did a case study for the QuickStrom paper where we tested, do you know this collection of front-end web apps called To-Do MVC, where they like implement the same To-Do app in 50, 60 different web application frameworks.
Yes.
It was like an old project, probably like 15 years old now.
I'm gonna say, I don't think, do they still maintain that?
No, I don't think so. Or maybe sparing me, but no, I don't think so. But it started with like the old one, like Angular 1 and Backbone or whatever it called, all of those, and React, and sort of went on. So that became a large collection of these. And I looked at that and was like, that is a good test case. Something like you have this old Oracle property thing going there. So I wrote a spec for those applications in QuickStrom, and we tested all of them. And we found like over half of them were broken. Bugs that were, to our knowledge, not like already reported. And it was various, like these were very kind of simple, but not super simple, but they had a little bit of state management and different state interacting with each other and stuff like that. So
you gotta add a to do. You gotta mark one done. You gotta take one away. Yeah.
And then it had like filtering, so you could move between the completed ones or the pending ones and stuff like that. And you could edit to dos, and then you have the whole interactivity with the UI. Like if you're focused there and you're typing while editing, or triggering a filter change or something like that, what happens when you're in these different sort of ephemeral states, maybe not states in the data model, but states in the UI. So anyway, that case study was written, the specification for the case study was written in this state machine specification style, which is very precise. Like it really tries to capture at least all the different ways that this system should behave. But I found like for, let's say, regular web apps, the stuff that I was doing at work when we used this was much simpler. We just had these very basic sort of safety properties and stuff like, anytime there's a spinner in some component, that should result in the spinner not being there, and there should be something else. That sounds like pretty stupid. Like, how much can that catch, right? But then you think about it, it's like, that's sort of like fuzzing in a way. Like it doesn't crash, right? That's the property. If the spinner, whatever component, actually produces something which seems somewhat valuable, even if the error, maybe you could fail on the error as well. But you could say like, okay, errors are okay. At least there is something which is not the spinner forever. So we sort of mapped that number that I spoke about, like the number of states, to a reasonable timeout. I've also experimented with not having that number, but having like clock time instead for those properties. The sort of requirements on time for each subproperty. But yeah, so my takeaway from that is like very simple properties actually capture a lot or provide a lot of value together with sort of the power of generative testing and randomness. It is fascinating, I think. It like sometimes,
Can I interpret that a little bit differently? So what I'm hearing you say, and feel free to correct me, is it is possible if there is an open tab on my machine, because I've started looking at PBT, that I have delved into the land of TLA plus, and I am aware that these more complicated things exist. But to really get practical value out of taking the approach, you don't actually have to be a genius in designing properties and making this work. And I'm saying this really hopefully for myself. Is that right?
Yeah, I think so. I mean, it sounds almost lazy, but setting something up, having some kind of basic properties, like things should never fail in a certain way, whatever it might be, and then just like having that run on a nightly CI, whatever job, whatever, it's not going to be super effective in like exploring your complicated state space, obviously, but you might find a lot of like low hanging fruit just from that. And like I know I'm speaking to like people at the company who are like industry experts in state space exploration, and it's going to be a little bit.
If you are interested in a more complicated state space exploration, dot.
I know. Like that is obviously valuable, but like for someone just beginning to like apply this and getting into it, I think there is a lot of value in like simple sort of smoke test like properties in a sense.
Yeah, I remember in the early days of React, React was made by Facebook, and Facebook is like, they have private messages, they have all of these things where, okay, if anything goes wrong, unload the page. Just unmount all the components, unload the page, you get a white screen. And this happened a lot. So even just the property, your web app should never turn into a blank screen, would have caught a lot of bugs that instead people just saw. Like I saw so many of these on so many different websites.
Yeah, and it's funny, like we actually, on that work project, we used React and we had a property like that. There should never be a blank screen. And that actually caught some errors, like something crashing hard. Then I think React became in itself better to deal with those. And it had some boundary things for users to sort of error boundaries or ways to
error boundaries.
Yeah, something like that. Yeah, right. And we weren't using them probably, I guess, in the beginning, and we started like doing that and guarding this. So definitely, like this seems like a silly thing, but yeah. I also caught like data races in a React component. We had like a little search bar thing, and had some basic property. I sadly I don't remember specifics, but we had some basic property on that actually caught like if you typed exactly the speed or something, you could get a data race with like completions coming from a server and then overriding your thing and getting a different search result than you were supposed to have. We couldn't like reproduce that, which is like something we could talk about also in this context, like because QuickStrom is not perfectly reproducible. Like it's not a deterministic thing. But it did point us towards something. And then I think I wrote like a more deterministic property-based test for and adapting the code to be able to do that. And we caught the bug in a more reproducible way. So it was sort of there was some smoke. I could see the fire eventually.
Races in search is like specifically the one kind of bug that I hear the most people complaining about.
Yeah. That is like on the web, you see a lot of that stuff, right? Various just like, I don't know what to call it, but like UI races, where it's like stuff rendering and reshuffling and like depending on timing, everything just goes wrong and becomes extremely annoying. It's a slightly different problem maybe, but yeah, definitely.
Yeah, or like when you click somewhere, but something loads in under your cursor and you click on an ad that you didn't want to click on.
Exactly. Yeah. So yeah, definitely. But the reproduction thing is interesting, in I guess in this context as well. Like with property-based tests, you don't have like I don't think there's anything saying that property-based tests have to be deterministic and reproducible. Really, it's sort of in a sense orthogonal to that, but it's also very useful if they are. But it's obviously tricky to get to, and like if you're doing property-based testing in, let's say, in your how would I describe it? Like in your code as a testing framework, not like QuickStrom running on a web page, which is a lot more black box. But okay, let's say white box testing. I mean, it sort of takes a lot of discipline also in how you structure your code and making it testable in that sense. I was working on this very recently, trying to do sort of a very lightweight DST-like thing, which is obviously in this area as well with antithesis, and that takes a little bit of massaging your system under test. It was approachable in this case because we were running TypeScript and Bun, so I could use there's this sort of fake timers library then you can use and sort of inject mocks and controllability of side effects. Otherwise, yeah, it's a bit of a tricky area. And with stuff like QuickStrom and black box testing with real browsers, you lose the determinism, you lose the reproducibility. Even if you could control the client side, then you have the server side as well. Yeah, so it's a very different trade-off than property-based testing in that case. And like I invested a lot of time on QuickStrom to have a nice like reports UI. So if it found a failure, you got this web page, just a single HTML file with JavaScript baked in, so you can like navigate all the screenshots and see what the state was of each element that was relevant in that page and what the formula sort of evaluated to and so on, which became very valuable because that's the only artifact you have really. Like then it's like a log, and that's what you got. So
interesting. So Oskar, I don't think it's a secret to say that property-based testing is not very popular. It's very popular among a certain group of people. Don't get me wrong. I'm wearing my purple shirt today. But it is less popular amongst the population at large, or larger, I should say. Why do you think that is, particularly as you sort of walk up the stack? And I'm going to venture a hypothesis, which you can feel free to poke at and completely shatter, which would be, it almost sounded like as you were talking through moving up from verifying that sort and reverse and things work as expected into making sure the UI is assembling itself correctly in all the cases we would expect. That starts to veer a lot into basically expressing user journeys as some sort of calculable state, right? Where it's like, I often use my mom using Facebook for this. So we've been around this a few times, but my mom has no idea what property-based testing is. But she knows that if she creates a post, it probably should be there and it shouldn't blank out on her, and it should be there tomorrow, and no one else should be able to edit it. And if she deletes it, it should go away. And that's now a set of basically like CRUD operations that anyone implementing any sort of data ingest and processing and storage and redisplaying can now use as a template for working through things. But it's getting higher and higher level. Do you think that's why we have seen it struggle to be a little bit more popular?
You mean like why it doesn't get popularity at those levels, or like less and less popularity?
Well, I can literally feel it tugging against a different side of my brain, and that may just be me. So like, we drift out of math and drift more into people. And do you think that's one of the barriers that's preventing people from diving more into property-based testing, or is it is it just a lack of good materials that are out there in order to show the different paths to getting value out of it? And that could be a false
Yeah.
choice. Feel free to say that as you
Yeah,
like.
yeah. It is interesting. I don't think I have a very like definitive answer on this. There could be something, as you said, like it sort of moves out of the technical realm in a sense. It's still technical, obviously, but it's sort of higher level, more product businessy think in a way, which may not like overlap so much with the people doing formal methods normally. I don't know. Like they might prefer sticking around the back end. I don't know. So there could be something there. I think also like it's sort of like these testing pyramid models where you have lots of unit testing, you have some integration testing, you have like a few end-to-end tests. There might be some sort of the same distribution going on here. Like your tests are gonna be slower, less effective, and at this level, like you can't run millions of these browser tests, or it would be extremely expensive or take a lot of time. So, I mean, the effectiveness is, I think it's like a complementary thing that you can use to, because like web testing is, if you do that manually, it's really hard and really frustrating to work with, like all these web scenario testing things that you have to write scripts for and all that, and they're still very slow and like all these. So I find it to be a nicer way of doing that kind of testing and a way to get more coverage, but still like it's very limited, and you probably need to complement it with something else, and you probably should use like a regular property-based testing framework for your unit testing needs, so to speak, and maybe complement upwards like that. Otherwise, I think it's like a very just underexplored area, and I don't know why. Maybe because of like all the complexity. It is more moving parts, and like browsers and having also like test automation for browsers, for instance. That's a pretty new thing. Like that hasn't been around. Like when was it? QuickCheck was like early 90s something. I don't think we had a single automatable web browser back then because basically didn't have anything to browse. So, I mean, we're pretty early in this as well to have all the infrastructure to be able to do something like this.
Maybe that's the exciting take, is that this is actually still very early ancient history on this front. And anything we can manage to scrabble or scribble on the cave painting wall will be very much appreciated by those who stumble past in the future. Is that right?
Yeah. I mean, if you look at it from just a sort of a visionary stance, then I mean, being able to just take your completed product with its UI and shove it in somewhere and say some magic properties on how it should work, and then have it be tested, that sounds good. Like as an alternative to just not have your UI tested. I find that a very compelling vision, even if it's not going to work out that way in practice, maybe, or at least not right now, even with the AI. You still need to do the work, but like a lot of tools, I can imagine a lot of tools being written which haven't been written yet, and it's not like impossible mountains to climb. I don't think so. Like there's so much more to do in this area, which I think could be very useful.
So what do you think the next, let's say, 5 years of innovation in this area would look like?
Yeah. I do think like QuickStrom was I guess innovative in certain ways, but also kind of simplistic. Like it didn't have any sort of equivalent of coverage guidance generation or mutation. It's basically just random and sort of, let's say, stateless over time. Like previous test cases didn't inform later test cases, that sort of thing. There was no test database, nothing like, I know like Antithesis has these sometimes assertions, which are sort of CTL related, is sort of, you you sort of quantify over different test cases or different traces and say like, I want to have like 10% of my test cases be in this area of the web app, whatever. Like you could have these sort of meta properties.
Then we had a research PBT framework. In addition to our actual product, we had a research PBT for our JavaScript notebook. And there we also had sometimes assertions as just a tool for making sure that, okay, we're actually testing this thing, or okay, we get the non-trivial test case sometimes, because sometimes your generators are just going to give you something trivial and you want to do the trivial thing, but you don't want to do that all the time because then you're going to have bugs and not find them.
Yeah, exactly. Like having just tools for measuring that stuff, it's like first step, I guess. And then stuff for like more intelligently having a tool or platform, whatever, being able to use that to generate better examples automatically. And I think QuickStrom doesn't do any of that. And I think that's a very promising area also because of the speed limits, so to speak, with browser testing. Like if you have, so for instance, in property-based testing or like DST, you can like rewind and say, you can backtrack and say like, oh, we did the 5 last actions didn't really lead to any specific state space exploration. Let's go back 5 steps and branch off there instead and do something else, right? Even if that is implemented as a sort of stateless thing, you actually restart the whole program and just do all the steps up to the last 5 ones, and then you take another path. If you have some system that takes like very little time to execute one of those traces, that is retractable. You can sort of just branch out and do some kind of search. In the web case, that becomes problematic because it's so slow. So you might not be able to do any meaningful searching within like a session. And then you might need to spread that out over time instead and say like, okay, we can only realistically run so many test cases a day. Let's do that. But let's also like collect data on how these test cases, what they see and what they find. And
intelligent allocation of scarce resources. Because it sounds like these things, if you have a whole browser automation framework, if you're running this in a browser, it sounds like this is going to be fairly slow, and it's not turn it on for 2 minutes and see if it's not like you write your branch, you turn it on for 2 minutes, and you see if that flushes out any common bugs, and then you just iterate on that until all of the common ones are gone.
Yeah, no, it's going to be a lot slower. And maybe obvious ones, but I think the value is like randomness over time in this case. And then you have to deal with the problem of like, if you build this sort of test database in a sense, or state space map, you could think of it as, then the system under test changes as you build this map as well. That becomes complicated to like, how do you map it out in a semantic way rather than a very sort of technical physical way? It's like the nth element on a web page might not be the same thing anymore. Like you might need a more stable identifier for that, sort of the button or whatever it is. And if it changes its name, or someone says that it shouldn't be called login, it should be sign in, and then all your test history is screwed. So yeah, that is an interesting thing. I think there's a lot more to do there. And there's also like a lot of research and prior art in this area, which is more for like things that are fast to execute, like fuzzing and that kind of research. How much we could like take from that and onto the higher levels and slower to run tests like UI tests, I don't know. But I find it very interesting because it could help make those techniques a lot more effective.
So it sounds like your vision here is sort of, on the one hand, we have this fuzzing area that's about, you have AFL style intelligent allocation and coverage guidance. And I've heard that something that OSS fuzz, I believe it's OSS fuzz, something that somebody does is whenever you find a crash in a program, whenever you find a bug, you save that input and that gets added to a library of unit tests or things that will be used to generate further inputs for later versions of the program, sort of addressing the shooting at a moving target problem. And then on the other hand, you have PBT, where a lot of the time, okay, maybe there's not so much coverage guidance, maybe there's not so much anything more intelligent than a user goes in and manually specifies, here's the weight that we want to assign to this generator, so we want to do this thing more than that thing. Sort of bringing these together once you've flushed out the common bugs, because your bug distribution is going to change over time. So once you get the common bugs into, you turn it on for a second and you find these, or you have your unit test library and you pull the rare bugs, the long tail of you're not going to find this in 5 minutes, you're going to merge your branch and you're going to run CI overnight, and the nightly tests are going to catch this. You're going to come in the morning and go, oh, there's something wrong with my branch. Okay, I have to fix that. It would be much better for everyone if we could pull that into sort of the find this within 5 minutes range. And then there are the bugs that you don't find and you want to be able to find them at all. So is that a fair summary? I guess as testing becomes more sophisticated, it then has to become even more sophisticated to offer more improvement.
Yeah, I think so. That's sort of a nicer way to put what I tried to say before with like, when you start, it's just like having some simple properties and just randomly generating a sample is probably a good way, because you're going to flush out some things which are like low-hanging fruit. But then as time goes and as your testing matures,
eventually you have to become a giraffe.
I'm the property-based testing story and like the regular sort of mainstream property-based testing frameworks has been, I don't want to say disappointing, but it sort of leaves a lot to be asked to ask for still. There was some work in QuickCheck, I think, measuring sort of logical coverage in a way. I think of these things as like physical coverage and logical coverage. I know those are not the correct terms. They're probably like, what is this, like semantic coverage and structural coverage or something. But you sort of get the point. Or ways you can just say like, I want this expression to be true, 20% of my tests, and then the testing framework can sort of try to generate cases which get those statistics in ranges. But otherwise, I've not seen so much in sort of FP property-based testing land, and fuzzing has been. That space has been appealing to me the last few years. I've been looking more at that and how I've now been experimenting with stuff like concolic testing and coverage guided testing and mutation, sort of combined generation and mutation approaches. So I think there's a lot there, and it's also interesting, like in the web space, how much you can integrate with the browser to extract information. It's like, if you don't have a full deterministic hypervisor, then maybe you can at least have a browser which you can sort of instrument your code on and get some stuff out to guide stuff. Depends on like how much. Web apps are complicated beasts with the server and client side split, so might be less effective in some cases. But if you have like client side heavy systems, that could be interesting also. See if some of those fuzzing techniques could be sort of carried over.
Yeah. Be careful what you speak into existence, Oskar, because someone's going to decide that there needs to be a DST in WASM, and there's going to be all these kinds of crazy caveats, and it's just like, oh, gosh. But with that in mind, Oskar, thank you so much for joining us here on the show today. That's all the time we've got, but I hope everyone listening got a lot out of today. Thank you so much for listening, and we'll catch you next time.
Cool. Thank you. Thanks for having me.
Thanks for checking out the Bug Bash podcast. If you want to reach out, maybe with an idea for the show, or maybe you want to be on it, send us an email at bugbash@antithesis.com. Or if chat's more your style, head over to antithesis.com and scroll to the bottom, where you'll find the link to our Discord. Until next time.